Okay, this is exercise 312 that we looked at in class, and it takes a little bit to get all of it. I have great confidence that their answer is backward in some notation or interval size, but we'll get to that first. We need to think about a uniform distribution. Because they ask us to show this, and so I feel like we need to show it using a mixed PMF PDF. And so a uniform distribution from, say, on AB, well, a continuous one here. So that would just be a PMF, f of x equal 1 over b minus a, and we can see that works nicely in that if I look at f of x, the integral from a, well, and this is, so again, this is on AB, so the integral from a to x of 1 over b minus a ds, that just gives us x minus a over b minus a, and so we see that f of b is indeed b minus a over b minus a is equal to 1. Okay, so that's what you would normally go with. However, if you have shortened this probability distribution, you know, if you've added something on at the beginning so that this shouldn't end up being 1, so suppose it should end up being some value p, then notice what you would need to do is you would have to multiply everything by p. So if instead of 1 I wanted p, I'd have to multiply there by p, which means I'd have to multiply there by p, and multiply there by p, and so this would be a p. If we didn't want it to be 1, if we wanted it to be something less than 1, we have to multiply by that. So once we get our distribution based on the length of the interval, then we need to fix it up by a p. So given that, okay, we're told we have a particle at rest at t equals 0, and we're going to do a uniform distribution of t, so 0 less than t less than 1, and we'll generate some t0, and this is where I really think you need some different names than everything just being lowercase t. So we generate our t0 inside this interval uniformly. And so then the probability that this t, our random variable t, is less than or equal to t0 is t0. Okay, that's that probability. And so the probability that t is greater than t0 is then 1 minus t0. Okay, so we have that, and so now we generate that t0, and at that point we give the particle velocity v, at t0. And so then it makes its way, then distance is v times t minus t0. Okay, and so the x max is going to be when little t equals 1, so v times 1 minus t0. That's the largest it can be. So what happens here? Okay, so as we look at our joint distribution, or not joint distribution, sorry, mixed distribution, it's going to be 0 as long as x is less than 0. And then at some point, it's going to jump up when x equals 0. That's going to be that spot at t0. Well, what was that probability? That was t0. So there's t0. And then the rest of it is going to be this PMF. Now, our x max, it goes from 0 to our x max. And so I'm going to start this as saying, oh, okay, this is just, I would go with 1 over x max. And we'll write that down as this stuff here in a minute. X greater than 0. And of course, it will only go to x max, and then after that, it's 0 again. So actually, I suppose I should probably write that a little better. 0 less than x less than or equal to x max. Now, but that's going to be off because that would give me a total probability of 1 plus the t0. So I have to shorten this up or bring it down by that 1 minus t0. I have to multiply by that because that's how much I have left to use. So if I multiply by the 1, I get a 1 minus t0 here over x max. Okay, so that's my PMF. Now, so that's equal to 0 t0 and 1 minus t0 over, now x max, remember, was v times 1 minus t0. Okay, so we have that. And of course, again, that's x less than 0, x equals 0, and 0 less than x less than or equal to v times 1 minus t0, or x max. Okay, now we can simplify this into just 1 over v. And so if we look at f of x, that equals, and again, well, that's 0 if x is less than 0. It's equal to t0 if x is equal to 0. And it's equal to t0 plus the integral of our 1 over v from 0 to x ds. And so that is where they get their, if we assume that x can only be between 0, so if we quit worrying about that, we can put these two together as a t0 plus the oops, I don't need the integral sign, I can do that integral. And that's just x over v. And this is for 0 less than or equal to x less than or equal to v 1 minus t0. And so, you know, if I plug in that x max, so f of v times 1 minus t0. That's equal to t0 plus 1 minus t0 times v over v. Well, those cancel, and we just get the t0s canceling, and we get 1, just as we should. And so, yeah, the textbook, they just had those backward. Not sure how that happened in their write-up for the problem, but they just, in that solution, they just had those backward. And so then, in part B, they're just, so that was part A, they want to know the probability that x is greater than or equal to v over 3 when, and I take it as t0 equals 1/2. Okay, so the probability, that would be the integral from v over 3 to v times 1 minus t0, right, because that would be x max. But 1 minus t0 is just 1/2 as well, so we would get v over 2, and we have our t0. Let's see. Oh, well, actually, this could be with the t0. Well, those will cancel. This t0 will cancel in both cases anyway, so it doesn't really matter. Let's see. So I have my 1 over v ds, or well, actually, I can use dx now. Okay, so I'm just using our PMF. I guess that's here over the 1 over v, and so that is equal to the v's are all going to cancel, and so we have 1 over v times v over 2 minus v over 3. And again, those cancel, and so we get 1/2 minus 1/3, which is 1/6. So I have not checked the answers on that. Let me go check that. Hopefully I got it right. If we have the answers for that, 312. How about that? That answers, that's the same as the back of the book. Okay, so the book says, yes, indeed, that's 1/6. And so, yay. Okay, we got that. But again, they just, I'm not sure what was going on there with how that happened, but mistakes like that happen. And so they just had their 1 minus t versus their t. Everywhere you see a 1 minus t, you should put a t. Everywhere where you see a t, you should put a 1 minus t in their problem description there of the graph. But there we go. And we got to their book answer, so we probably are doing okay.